You know, when I worked in RCA, the guys in a different room would come over to visit, and they were more technical. They worked on a thing called the Star Machine. It was an all relay computer, and it had an A to D converter in it. What it would do is you'd put a tube in a socket and a tube in a second socket, and it would test each tube and run a chart for each tube with stars, you know, with an asterisk. So you actually got the amplification of the tube at different voltages done on a teletype on a piece of paper. So you could sell someone a matched pair, and that's when the tubes are new. Okay, a matched pair can drift apart from each other as they age. But anyway, those guys would come over, and if you were doing something and you weren't doing it perfectly, they call you a shoemaker. And the reason they call you a shoemaker is a shoemaker can hide a lot using a lot of glue and a lot of little tricks. But when you're a shoemaker, it's an insult. If you're an electronic technician and another technician calls you a shoemaker, it means you're cutting corners and you're not doing it right. And they would come over and question everything I did, just so they could drop the shoemaker insult on me. And it was sort of a cat and mouse game with them, but I did okay. Now I wanted to show you this. Remember I said a 455 IF can? Well, it's not. And in order for this to be a BFO for this type IF, you'd have to open this up and take the capacitors out. This was not wired in. Instead of making a nice bracket, he made the bracket first and then drilled an extra hole in the chassis. See, what I would do is, if I had to put this in this radio, I would measure the distance between these two holes and then make the bracket match so it wouldn't be a shoemaker. Okay? Yeah, it works. It holds it, but it's a shoemaker. Okay? That's what the guys would call you. Why didn't you make the bracket match the holes already in the unit? So in the future, if somebody takes this out, it won't look at it. It's all kinds of, he never took the burr off the hole. Pretty funny stuff. And then he labeled this IF can down here, and that means that's been tweaked. It's supposed to be, I don't have my glasses on. All right, let me put my eye loop. One of those things are getting old. It's supposed to be 239 kilocycles, and he's got it set for 235. So that means that's been touched. Okay? And then this thing, it seems to be missing the bolts that hold it in. Okay? So we got to double check this thing. It's been opened. This one screw. Hold on. It's tough. I got to go into eye loop. It's been opened. See, there's magazine articles where they tell you to go inside these three coils and you take off a certain amount of turns. And I'm going to tell you this radio here, as a Q5er, the IF cans are too wide. What you want to use for a Q5er is the long wave radio. It has 18 kilohertz, or 85 kilohertz, or kilohertz, not or kilocycles wide IFs, and that's why that one is the most coveted. Now you can set this radio up to receive a different radio, but it would only make it a dual conversion radio. You wouldn't get the narrow. For CW, it wouldn't be more. It'd make it a little bit more narrower, but not like if you use the long wave receiver, which is a BC 455, I believe. It could be a 4552, but anyway, yeah, this is pretty interesting. But you know, as I'm looking at the other video before I put it up, I noticed there's no wires on this, and I'm like, wait, how come there's no wires? And then as I dig more, I'm like, why is there an extra pot up in the front? And I don't know what that controls. It could have the tube set to regenerate, and if you regenerate, that works as a BFO. All right. When he couldn't get this to work, he made one of the tubes go into oscillation. Notice these are shielded wires, and then these are actual braid, and then over here he's got spaghetti over them. But this is a real mystery. But I only pulled this one out because I'm working on a different one, and it hit me. I'm like, it's been bodged. Okay, just the fact that that's a different frequency. That means he's turned the little screws in there. So that one, this one gets taken apart, but it's not the one I'll be working on. And the one I'm working on is absolutely hilarious. Okay, I'm still in the process of getting this transformer out. All the bolts and nuts are rusted. You know, this is an aluminum chassis. All right, the bolts that come with this are brass, and the person put on steel. What he had, he used what he had. They're all different sizes, and but I'm starting with this one because this is this one's got some wackiness too. This volume control up here actually turns the voltage on and off of the power supply, and he didn't drill any holes on the front panel for what would it be, a jack. Where did he put his sound jack? What the hell? Huh, I wonder how he got the sound out of this thing. Well, anyway, I don't see the holes. That's good. That's good. Okay, so this is the one I'm going to work with. I just wanted to show you, you know, if he was going to make a BFO for this unit, this frequency would have to be lower. And the other thing is this would have to be opened up, and the capacitors be taken out. But like I said, this is I don't know what he got this from. Pretty cool. He did improvise. He took something off something else and made it work, but he didn't finish it. So that's where we're at on part 2, and hopefully I can get this transformer out. And it's a nice transformer, but you can tell this was used when it went into this radio. And then I have to put back in the shock absorbers, and then there's a connector that comes up to the for the dynamotor. I have to have that for my power supply. Here's one of my power supplies. Let's get it in the frame. Notice it has 3 different colors now. I took it to an all new level. My power supply. That's the old cord. A lot of this is an asbestos wire too. There's a lot of asbestos wires that the guy added into the radio. Only the best. 1959. A lot of your surplus was asbestos wiring, and you know, this brings back memories because in 1959 I was working on a wireless microphone. 1959, 1960, right around there. And my uncle, he could take a joke to the point where it was really obnoxious. He worked with my dad at the TV repair shop, and he kept saying, "Oh, how does it get to the radio if there's no wires?" And I explained, but he just that was just make himself feel big, you know, keep picking on me. And the reason my transmitter didn't work was I didn't know about reversing the tickler winding in an oscillator. And later on, when I built the same circuit again, I reversed the 2 wires, and it worked. And it was a circuit out of an old book, and the book wasn't wrong in a way, but it never mentioned that if it doesn't oscillate, reverse your wiring on the tickler coil, or wind it in the other direction. Okay, they didn't do that. Those are the things that you'll find out about circuits. Somebody will print a circuit, and they won't put that note in there that the tickler winding that's wound over the coil. First you have the coil that is at the right frequency, and then there's another coil either below it or wound over it that when you hook it up, it might not oscillate. You have to reverse the 2 leads, and then it'll work. And that's why once I wired that up, I knew I had the coil in wired the correct way, but of course the windings were going the wrong way, and there was no convention on that circuit to let me know that, or I didn't know it. But then years later, I found it. I think it was in the book of things to make. Well, anyway, I went back and I revisited it, and I wired it up real quick, and I realized that's where it was bad. And it used like a 30-volt battery and a D cell, And I remember my mother buying me the 30-volt battery. We found a store that was still selling them. And, you know, it is what it is. It's one of those things where you do everything right as far as what you know, and then years later it hits you. Like I told you, the thermistor, I coated it with epoxy and it wouldn't be linear. And the article said, you know, coat the thermistor with rubber cement. And I'm thinking, okay, I don't have rubber cement. I'll use epoxy. Well, rubber cement would expand and contract, but the epoxy on the thermistor kept it from expanding and contracting. And it hit me one day. It hit me years later. I'm just sitting there, and the brain goes, "Hey, remember that thermistor? It would always read nonlinear. That's because you coated it with epoxy, and it couldn't breathe out and it couldn't breathe back in." I'm like, son of a bitch. So then I went back, and I still have the thermistors, and I put it in a plastic tube. And I had looked at the Radio Shack one on their thermometer, and I said, "Yep, that's the way to do it." But see, in my mind, when you put the thermistor in a soda straw and seal each end, it takes a while for the temperature to penetrate the surface skin of the soda straw, the plastic soda straw, and then heat the air up inside. So when you're calibrating, it's going to take forever to settle down. And by coating the thermistor with a thin coat of it protects the thermistor, and it also keeps the wires from shorting out in the water, because you go between ice and hot water. But stuff hits me later on. But you know, I stay with stuff till it's painful. Okay, and I like this type of work because I've done it before, and I take my time. You know, and you got capacitors in here that I have to use the cap checker. And over 2 years ago, I showed my cap checker, or a year ago. And I found someone else got the article after I mentioned it, and then they redrew it in their own handwriting, passed it off as their design. I thought that was pretty good. I had that happen once before. I had a guy asking me questions, and I'm like, why is he asking questions? I clicked on his name, and he went and did one of my videos over as one of his videos. It was sad, okay? And he never did it again. He gave up. You know, it was like I was going to teach him electronics, but he wanted to be me, I guess, in some way. But you don't want to be me. I'm a tortured soul. Me and my other friend, we used to say that all the time. We're tortured souls. The more you get into something, the more annoying it can be. But there's going to be a lot of work on this, because he cut a lot of wires and rerouted them. And I think all three radios have been wired for 12 volts. They're no longer 24 filaments. 3 strings in series, 3 strings in series, and then in parallel. And this was set up for either 6 or 12 volts. And it's going to be a lot of work. And this is freed up now. I can get the capacitor to move on this one. But that's a nice capacitor. Is it in the frame? This is a nice capacitor. And like I said, there's a lot of plates on this. And it is possible that this is the same capacitor in the AM broadcast band as in the long wave. Okay? But the other thing too is, I don't want to mix them up. Yeah. That capacitor has been adjusted to go with this. Okay. Now, if you look at the plates very carefully, you'll see that each gang of capacitor has one that's adjustable, and they adjust it so it tracks linearly with that coil set. So it's very important that you keep this tuning capacitor with the matching coil set. Okay. And then the IFs, all 3 of these are different. Okay, one's IF 1, 2, and 3, and the first IF is wide. The 2 coils inside are very close to each other. The next one, they're further apart, and IF can number 3, they're real far apart. And you can see it on the drawings. Like I said, there is a set of schematics for these radios. It shows you the schematic, parts list, It also shows you the pictorial of how these are wired up underneath, and they exploded it outward, so it's very easy to follow wires. The problem is, in this case with this, is a person's taking wires out, and it makes it a little bit more difficult. But you just take it section by section, step by step. But it's really sad that they did this. I mean, they could have made the plate that this went on that mounted on the shock mount, and the radio would remain original. But they didn't. You know, the first few paragraphs, remove this, remove that, take this out, throw this away, substitute this. So you take out a really good audio output transformer that's meant to go to headphones, and you throw that away, and then you put in a cheap 50,000 ohm to 8 ohm transformer. All right, so you take out the thing that's already there and throw it away. Where, like I said, you could put a transformer in your speaker, and you can use a regular filament transformer. Just put the low side, which would be like 6.3 volts or 12.6. Put that to the speaker, and the other set of leads, which are black, you run them out to your wire, and that's your high impedance, and it works fine, especially if you have to set the radio for 800 ohms impedance. That's not what it measures with a multimeter. It's impedance at 1,000 cycles. I actually know some of this stuff. It's in my head. It's in there for 60 years or whatever. But I just want to show you, we're still working on it. And these bolts that hold this on are all rusted. I got the nuts off, but the rust is holding the, he put these quick, they look like star washers, but they're click nuts. You push them on with a tool, and they're on there. So even though the nuts are off now, the transformer's still on the chassis. Pretty funny stuff I'm finding. But each person has their way of working. Now, I mentioned at the beginning of this video about being a shoemaker. They got me so crazy at RCA, and then they would always go, oh, I'm only kidding. It doesn't really matter how you do it as long as it works. But they really didn't mean it, okay? Because anytime you would do something new, they would check it out to see, you know, like I said, if you got 2 holes already there, you don't put a 3rd hole in. You utilize the 2 holes. You put the hole in the item that you're trying to attach, and that way, if it ever changes, it goes back to what it used to be. Now he's got little holes in there. I didn't find a hole for the microphone. No, or for the headphones. That's good. This chassis is going to be good. Okay, I think that's it. All right, that's it.